Here's a list breakdown of everything you'll need in order to make this circuit with the OR logic gate. A breadboard. I recommend a medium-sized breadboard. You have to power up the breadboard somehow. The way I'm doing it is with the 9-volt battery cell, 9-volt snap-with plug, and a 2.1mm barrel jack. The barrel jack is connected to the breadboard directly, and the 9-volt snap connects the barrel jack with the power supply. Now, as for the wiring of this circuit, we're going to be using 22 AUG copper wires in two different colors, the red for power and input, and the black usually for ground. Now, there's another option to use jumper wires. These are 12-inch male-to-male connectors. It's not completely necessary, but it does make your circuit look a little nicer. In order to cut some of the wire, you'll need some sort of wire stripper. Interesting part of the whole circuit. So we have our actual logic gate, and this is a quad 2 input OR gate. We'll discuss about the schematics a little later. What we'll be lighting up are these green LEDs. I got in a pack of 4. You can use any sort of LED you'd like as long as they have an anode and a cathode and any color you'd like. And of course you need resistors, and these are 330 ohm ones in order to make sure our logic gate and LED aren't damaged. So the thing we're going to do is grab our OR gate. Now you'll want to put it somewhere maybe around here in order to leave space for the rest of the output. And make sure you really plug that in. You should hear snap from both sides. Now you'll want to have it set up such that the semicircle here is facing to the left. And based on the schematics, we know that the pin configuration goes as follows: pin 1, pin 2, 3, 4, 5, 6, pin 7, which is ground, 8, 9, 10, 11, 12, 13, and pin 14, which is for power. Get out your 2 pairs of 22 AUG copper wire, and we're going to cut a small piece of wire from each of them. So I got my 2 pieces, and right now they have no copper sticking out, and so we're going to have to use our wire stripper cutter to expose them. There's one part exposed. Alright, so we got both sides fully exposed with the wire. Have your 2 wires ready and exposed from both sides. You're ready to implement it on the breadboard. So first we're going to ground this logic gate, and in order to ground this, we have to first connect the black wire to any part of pin 7, which we know from the schematics. So this is pin 7, so anywhere in this vertical rail is acceptable. Now where we connect it to is the horizontal line that is adjacent to this blue line, which signifies ground. So I'm going to put it right here. And there you have it. Our pin 7 is now connected to ground. Now it's time to implement the power supply wire on the 14th pin, which is right there. So anywhere from here to there is acceptable. Once you choose that, you connect it to, instead of the blue line this time, you find the horizontal rail that is adjacent to the red line, which signifies positive. So and now we have pin 14 connected to power. Find your LED now, and you'll notice that one of the sides is a little longer than the other one. From my view, the left side is longer, and that's what we call the cathode. The cathode is the positive part of the LED. The smaller side on the right is called the anode. The anode is the negative part of the LED. When placing the LED on the breadboard, make it somewhat close to the logic gate and the cathode side closer to the logic gate. cut out more pieces of wire, and these will be used for our input-output wires. Some people like to differentiate inputs and outputs by maybe a yellow wire, but it doesn't really make a difference. Now, based on the schematic, we know that pin 1 is an input. So let's place one end of the wire there. Pin 2 is also an input, so I'm going to place that there. Now I'm going to connect both these to ground at the moment. So these ends of the wire, they're going to be close to the blue line. So now both our wires, our input wires, are grounded. Lastly, we have pin 3, which is reserved for our output. And the way we do it is that we connect it to pin 3 to the anywhere on the vertical rail where the cathode sits on. Now what that means is that, do you remember putting the cathode on one side? So this is the cathode, the left side, the longer side, it's going to be here. So we're going to connect to pin 3, and there you go. So pin 3 is now connected to the cathode of the LED. This part is important if you do not want to damage your LED or your logic gate. And you guessed it, it's about resistors. They help by making sure that not too much current is flowing through these. It works as a current flow regulator. So we have to connect this with the LED, but this time the anode side of the LED. So the other side, the smaller side. And the other end of the LED resistor will be connected to ground always. So just like that. That's it. You've built a logic gate circuit with an OR gate. What's left to do is to power the breadboard, and we're going to need our 9-volt power supply, as well as the jack barrel, along with the 9-volt snap-with plug. I've already connected mine. First, plug in the jack barrel to the breadboard. Now notice that the breadboard here, the bottom part, it's top positive, bottom negative. My barrel jack is also top positive, bottom negative. So we're good to go, and we can just place it anywhere along this rail, so long as the directions stay the same. After that, just plug in the power supply. Okay, so now that it's connected, we can test the circuit. The LED isn't doing anything right now. It's because, why? Because both our inputs are at 0. It's at low. This blue bar indicates where it's low. Now the OR gate says that if one of the inputs or both of them are on or high, then the LED or the output should be high as well. So let's have input 1 at high to see what happens. I'm going to put this back to ground. What about for LED 2? If I put that to the positive rail, what will happen? And the LED turns on again, because as long as one of the inputs are high, the LED is also high. Now what happens when both inputs are high? Well, let's see. So nothing changes, because as long as both of them or one of them is on, then the LED is on. Now let's put both of them to ground. And it's back off. That is a simple circuit involving the OR gate. it completely follows our truth table, which tells us that the inputs being at 0, 0 will give us an output of 0, which is off. 1, 0 will give us 1. 0, 1 will give us 1. And of course 1, 1 will give us 1. So thank you for watching. I hope you learned something today and a bit about electronics. And in our next videos, we will do other sorts of gates. So AND gates, NAND gates, XOR gates, etc.